All right, we'll actually not do that. We'll just start right here. So last night's homework was page 4 in your packet. You guys all did it. So I'm gonna go around the room, just right in our new order here. And you guys can tell me the answer. If you got it wrong, that's okay. Your classmates will help you out. So one thing I did say about this homework is, remember you were actually there looking at it. We did questions 1 and 2 together. So question 3, Carter, is yours. The water will become unsafe in 5 years. Observation, inference, or prediction?
Prediction.
Prediction. And what made you say that?
Because it says within 5 years.
You sure? You could have said it's a guess about the future, but future's good enough. Cassidy, you got number 4. Again, you're standing there looking at the glacier. So you're not Cassidy. You're Catherine. Catherine, sorry, Cassidy. Catherine, some of the snow on the glacier is powdery. So again, you're standing there looking at it. Observation. And how come? How'd you know? Yeah, I love it. See it? Or you could feel it. So you can look at the glacier and you see it's powdery, or you touch the glacier and you feel that the snow is powdery. So Felicia, how about this one? This one's they tried to trick you a little, but I bet you got it. The sample is 8 centimeters long, 5 centimeters wide, and 3 centimeters high. Not an inference, they tricked you. So an inference is a guess. They are not guessing that this is that big. It is an observation, but why it tricked you is because what did they use to make that observation? They used a ruler, and I did not take notes in my packet here, but why don't you all flip back to page 2, where we've got the definition of the word inference. Zach, what is the definition? I'm sorry, not of an inference, of an instrument. Yeah. It's a tool that extends our 5 senses. So instead of just looking at that and saying, oh, that's a little rectangle, now you can look at this sample and you can say exactly how big it is. It just makes your sense of sight a little more accurate. So sorry, Felicia, that one they were messing with you there. So it's an observation that uses an instrument to see how big something is. Did you need that much of a description? No, you could just say, I could see it using a ruler, something like that. All right, how about Sarah? You got a hot and humid conditions will continue throughout the week. Yep. Guess about the future. Right, you can't see it, can't feel it. Keith, how about you? There are many cracks in the glacier. Again, you're there looking at it. Observation, how come? Yep. How about you, Cole? The sample is white in color. Abso-freaking-lutely. Destiny, you ready? A meteor impact caused the extinction of the dinosaurs. It is an inference. How come? I think, yep. It's a guess. You're not sure, not positive. It's unknown. Okay. So it's not completely unknown, but you look at some observations, you probably they saw the impact crater. They were able to figure out how old the impact was. They know that's when the dinosaurs kind of went extinct. They put 2 to 2 together and they made a guess. All right, Jeff, you're on this one. So the rocks in the glacier are different sizes. Observation, and how come? You can see it. Now I will ask, did anybody think that was an inference? I would accept that if you can tell me why. Yeah, but that's an observation. If you can flat out see it, that's an observation. But I've had some people tell me this is an inference and there is a reason why. You could guess the sizes. The other thing is when they say in the glacier, some people think inside it where we can't see. But It was supposed to be an observation. I was implying, yes, you could see that they are many different sizes. Only if you have the right reason. So can you not see them? Okay, so if you can see them, then you're not guessing. Zach, keep it to yourself. Okay, so that's if you're then saying like they're inside the glacier and I can't see them and you're guessing, because you're going to learn later this year that rocks carry all sizes. So you'd have to explain an inference correctly, and it turns out you did not. Zach, last time I'm going to talk to you. Not earning a different seat. No, you're not earning a different seat yet. No. Cassidy, I actually think you have probably the trickiest one. I'll accept 2 answers if you can. Which part of it's an inference? You're right. The must have been transported by a stream. This part is an inference because you're guessing. The whole statement in general is a guess. Did anybody put observation? There is an observation listed in the sentence. The object is spherical right here. The rock is spherical. That's an observation. So that part of the statement is an observation. So they're telling you, here's a round rock. How'd it get here? It was transported here by a stream, which again, you will learn in a couple chapters. Rocks that you pick up that are nice and smooth and rounded are typically transported by streams. So again, I would have taken 2 answers there if you could defend your answer. And finally, so it looks like this is Catherine. So you're Caitlin. Caitlin, you got the last one. Some parts of the glacier will start melting in the spring. Yep. How come? I couldn't hear you. Yes, because they say the word will start melting this spring, which is another way of saying the future. No, but like I said, your homework is page 5. Homework due Wednesday, which is the 14th. Remember my #1 rule of earth science. I already told you guys this, but I'm going to remind you again. Read all the words, even if they look like directions, even if it looks like you don't need it, read it anyway. That includes reading pictures. To read a picture, you look at the picture, you read any captions, you see what the picture's trying to show you. My other suggestion, like I said already, is to cross off wrong answers. So if you're reading it and one of them is definitely wrong, cross it off. Also, read all 4 options and read all the words in that option. So yes, like Carter was saying, I am just checking for completion, but I want you to do it for realsies, because if you don't do it, yeah, I said for realsies, because if you don't do it, you're going to be completely blown away when we get to a quiz or the test and you have never seen a Regents question. So I'm only giving you 7. It'll take you less than 10 minutes. Okay.
When is that first quiz?
That is a good question. Probably sometime next week. I'll let you know. Maybe even not by the end of this week. I always give you warning. Give you at least 1 day to study.
Okay.
For quizzes, I don't give you a huge amount of warning, but at least 1 whole day. Like if there was going to be a quiz on Friday, I would absolutely tell you by tomorrow. Okay, fair enough. All right, we did not finish page 6. I asked you to finish it for homework. I'm going to go ahead and just give you the answers to that one. And if you have any questions, I'd like you to check with me. So I do believe we might have done a couple together. So this first one, miles to the sun should be 9.3 times 10 to the 7th. People in the USA, 2.5 times 10 to the 8th. People in the world, 4.5 times 10 to the 9th. So what you're seeing again is you always plop the decimal point between the first 2 numbers. Even in this 10,000 one, what are the first 2 numbers? 1 and 0. So officially it should have been like that, 1.0. times 10 to the 4th. That one seemed to trick some people up all day yesterday. Now, did we save any time by writing this with 10,000? No, probably not. But if they tell you to write it in scientific notation, you do it and you do it correctly. For your miles in a light year, 9.5 times 10 to the 12. This one tricked up people. The electrons in 1 amp of electricity. So stick with the same rule. Put the decimal between the first two numbers. Now, what do you do with that other 4 and the 2? You write. You don't just ignore them. You have to write them. So that's going to be 6.242 times 10 to the 18th. So they still count the same way. And dollars the US president makes in a year. All right, now going the other way. So now if it's I didn't even give you any negative ones. If it's a positive number, we move the decimal point that many spaces to the right. You do not just add that many zeros. That always seems to be a problem. You move the decimal point, you do not just add zeros. So in this case, we had this number, we had to move the decimal point 6 places to the right. There's 1 place, 2 places. Now I ran out of things. I'm just gonna make some, that's 3. Wait, 1, 2, 3, 4, 5, 6. That's where the decimal is gonna go. And then I put zeros in between those loops. So this one is 6,380,000. The next one is 9. I don't actually know this number. I'm sure if I stopped and thought about it, I could figure it out. With 1, 2, 3, 4, 5 sets of zeros. That's 15 zeros. So yeah, I don't even know that number. So 99, 960, with 15 zeros after it. And finally, this one's not so bad, 22,110. So like I said, hopefully that was just enough review for you. If you messed up 1, probably by miscounting, messed up 2, probably by miscounting, you're probably okay. As long as you understand the concept. We will use this throughout the year. And I'm just going to kind of expect you to remember how to use it for the rest of the year. If when we're using it, you're struggling, let us know. We'll help you out. But we will be using this throughout the year. All right. So we are, and those of you who are just in lab, this is going to sound really familiar. But we're going to just review graphing real quick. And this is why lab might have been a little confusing, is because everybody else is going to learn it first. But I did 4th period lab. I decided to do you guys early because of the assembly. You're going to have 4th period on Thursday. If you did not just have lab, ignore everything I just said because it doesn't apply to you. Anyway, graphs are huge in science. Science uses graphs all the time because graphs are really helpful so we can see like what happens when we change this, what happens to that. Scientists love it. I'll also say in science, it's almost always a line graph unless they specifically say make a bar graph or make a pie graph. It's almost always the information gets put in a line graph. So with that being said, we're going to go ahead and just review how to make a lab. Again, if you were just in lab, this is going to be review. If not, this is going to be what you're going to do in lab next time you go to lab. So we're going to be first reading about graphs, and then we're going to make one today, and then that's it for today. Ready? Mr. D's got it. Awesome.
Let's graph. Graphing is an important procedure used by scientists to display the data that is collected during the controlled experiment. Line graphs must be constructed correctly to accurately portray the data collected. Many times, the wrong construction of the graph detracts or takes away from the acceptance of an individual's hypothesis. A graph contains 5 major parts: title, independent variable, dependent variable, the scales for each variable, and the legend. The title depicts what the graph is about. By reading the title, readers get an idea about the graph. It should be a concise statement placed above the graph. Independent variable is a variable that can be controlled by the experiment. Usually includes time, dates, minutes, hours, depth, feet and meters, and temperature in Celsius. This variable is placed on the x or horizontal axis. The dependent variable is a variable that is directly affected by the independent. It is the result of what happens because of the independent variable. Example, how many oxygen bubbles are dependent on the depth of the water? This variable is placed on the y-axis or the up and down axis. The scales for each variable. In constructing a graph, one needs to know where to plot the points representing the data. In order to do this, scale must be employed to include all data points. It must also take up a conservative amount of space. It is not suggested to have a run on scale, making the graph too hard to manage. The scale should start with a 0 and climb based on intervals such as multiples of 2 or 5, or 10 or 20, 25, 50, or 100. Scale numbers will be dictated by your data. And next, the legend. The short descriptive narrative concerning the graph's data. It should be short and concise and placed under the graph.
All right, I did, oh, some of you already got ahead of me. That's okay. What I just handed out highlighters for is I want to find some really important vocab words. Especially those, wait, what were you about to highlight? Yeah, it's not gonna be on our list for today. So hang on with the highlighting in case if you haven't already, that's all right. Let's start with, can anybody, so it's about graphs. What are some important vocab words in there that have to do with graphs? Want to try again? Independent variable. Everybody find the word independent variable where it gives the definition. Maybe wait until you start highlighting until we find the exact thing we're looking for. Yep, so let's get the independent variable first. So the independent variable, it's in the third paragraph down. The independent variable is the variable that can be controlled by the person doing the experiment. I like to remember that independent starts with the letter I, which means I, like me, I can control it. You can control, and so then some people are like, well, how? The first next sentence says it usually includes time. Well, how can you control time? Do you have magical powers to make the clock go faster or slower? No, but how can you control time in an experiment? Okay, so one thing you can do is you can control the time, like you can control the stopwatch. That's one thing you can do. What it actually is implying is you control how long you let the experiment go on. Like, do you want to do a measurement every day for a year or for 10 years? Do you want to do a measurement every 10 seconds? So that's what it means by you can control the time. So most of the time is going to be the independent variable. And according to this reading, where do we put the time or the independent variable? I'm sorry. Where did it say in the reading? Independent variable is placed on the x-axis. So that's one vocab. And then Cole mentioned, I'm just going to circle that word too, because it's like super important. Cole then said, I guess we're going to do dependent. What's the definition of a dependent variable? The dependent variable is the variable directly affected by the independent variable. In other words, it's a result of what happens because of the independent variable. And again, this variable is placed on the y-axis. That's not you guys. You have about 10 minutes left. You know, it's so confusing. Oh, that's good. That's a good thing. I was worried you were going to tell me it went by really slow and you were ready to leave already. I mean, I know you're ready to leave, but yeah, no, so am I. I got you. But I thought that's what you're going to say. And I'm like, darn it. Going by fast is a good thing. All right. So those are the two really, really big vocab words for graphs, independent and dependent. Scale is important, but we're not going to over highlight this. I think you already know what a scale is. So I want to do the two vocab words that I know the Regents is going to use these words and people get tripped up by that. So now we're going to do this graph here. And Mr. D already read the reading about it. So we have two variables. We have either depth or number of oxygen bubbles. Stop and think a second. Don't shout anything out. Which one can you control? Can you control the depth? And don't shout anything out. Can you control the depth or can you control how many oxygen bubbles a plant makes? You can control the depth. Again, not meaning you can control how deep it is. What you can control is how far down you take a measurement. You get to decide that. And then if you are stuck, stop and ask yourself, can I control how many oxygen bubbles a plant makes? Anybody have that kind of control over a plant? Not last time I checked. So the independent, I'm going to write that right here. Independent. And these two. Now, why are there two different sets of oxygen bubbles? Two different plants. There's plant A and there's plant B. How are you going to show two different plants on one graph? Two separate lines. You can do the lines with either different colors. So you have a pen and you have a highlighter. You could do it with a dashed line or a solid line. Oh, while we're still here labeling, the independent variable, does that go on the X or the Y axis? X. So I'm going to add that this is the X, which means this is the Y. And I am taking for granted, you know which one's which. X is the flat one. Y is the up and down one. Now I do apologize. I meant to make it so you didn't have to flip back and forth, but I screwed up. Oh, actually, let's answer these questions, which we already did. Read these carefully. Which one is the dependent variable? We just talked about, we started with independent before, but which oxygen bubbles? Number of bubbles. How'd you know it was? I'm sorry, I am lazy. I skipped oxygen bubbles. And I would be okay with it if you skipped that. And so would the Regents. But how can we put into words that why we knew that? That's exactly what I would have said, Carter. And because you can't control number of bubbles. What is that independent variable and how do you know? I can control it. Ooh, a title. What do we got for a title on this graph? Still not you. Okay, you can start with that. Let's help Sarah out. The effect of depth on. Yeah, I like it. That you're right. So some of you are like, wow, that's a long title. And it kind of is. Could you shorten this title? What would you want to shorten it to? Like, this is great. I like it, but I know, like, I'm lazy. I don't want to write that much. Hmm? Well, I think we need a little more depth of oxygen bubbles. Yeah, maybe that would work. Depth of the number, how about depth of verses? So you're just, so that I know exactly what you're talking about. We're gonna skip the average because I see we're running out of time. So don't cross out the whole thing, but we'll just write skip for now. And again, those of you who are in lab, you see the dreaded naked graph, meaning nothing. It's just a piece of graph paper, which you will be given completely blank. You need to tell me which one goes where. So we already talked about it a couple of times now. Which one goes on the X, the independent or the dependent? Independent, the one I can control, and we already said that is that one, depth. Depth is down on the X, which means number of oxygen bubbles. On the Y. Now, how do we know how to put a scale on here? Like where do we even start? Let's start with depth because that's on the bottom. What number do we start at? Start at 0 first. So 0 goes right here. What's the highest number we have to go to? And how do we know? You just look, you flip over, depth only goes up to 35. So we have to go from 0 to 35. What are some rules for labeling? Got to stay the same the whole way across. So if you start by counting by ones, you got to stick with ones. Can we fit one? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 5, 6, 7, 8, 9, 30, 31, 32, 33. Crud, that's close. Let's go by twos. Do you like counting by threes? Threes would work. I am not a huge fan of counting by threes. You could count by fives, you could count by threes. Now, let me just show you if I counted by fives. 5, 10, 15, 20, 25, 30, 35. That's how far I go. So if I left spaces in between, that works. So here is 5, 10, 15, 20, 25, 30, 35. Oh, still only got me there. Let's try twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I'll stop talking out loud. Now, to me, that looks super messy. How's yours look? You were more neater than I was. Okay, so you could, and it does. So it doesn't take up much space, but is it more than half? It's more than half. That means it's as good as it's really going to get. Yes, I guess we could have officially counted by 1.5, but how good are you guys at counting by 1.5? Yeah, I'm probably not that great. I can get to 1.5, 3, 4.5 without thinking too hard. And then I got to start thinking. 6 is next. Yeah. I don't like thinking. So just stick with what's easy for you. One thing I will show you is, do you have to label every single line? No, actually you don't. Here, I decided to only label every 10. I still counted by 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This way is prettier to me. Makes me feel better about what I'm doing. Do you have to do that? No, this is also perfectly acceptable. How about for number of bubbles? What should we start at? Also start at 0. So now we're going 0 this way. What's the highest number we have to go up to now? 50. What should I count by? Fives, really? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. That's not even half the y-axis. So the general rule of thumb is to take up more than half of the paper you're given. 10s would be really crummy. 10s would get you to here. So we need something smaller than 5s and 10s. Sarah, what's the problem? 2, 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Notice, so there's so much to write. Do you want to write it all? No. Am I writing it all? I'm not. There's tricks to not writing everything and making it take forever. So I'm counting by 2s, but I'm only labeling every 10. So here's 22, 24, 26, 28. Here's 30, 32, 34, 36, 38. Sorry, 30. Nobody cares about 38. 40, 42, 4, 6, 8, 50. Perfect. This is not homework to finish it, but tomorrow on the board, when you walk in, it will say, start plotting the graph on page 8. Okay, what's your homework? Page 5. You have 7 questions. I promise you, it will take you approximately 10-ish minutes. Do it for realsies.